Good evening, everyone. Myself Deep Yadav, and today we are going to discuss some of the important topics, or we can say the terms that are the basic of electrical engineering. So, starting with this, as in our 12th, or you can say in our previous classes, we have studied some of the things like this was known as the charge. This was the charge, which whose unit was coulomb. Then we have studied the current, that was ampere. Then we have studied Coulombian force, that was F, that was Coulomb per meter square. Then we have electric field, that was defined as Q upon 4 pi epsilon naught R square, and in the Coulomb force it was Q1 Q2 upon 4 pi epsilon naught R square. So we have studied V also. This was known as the potential, but that was defined as E dot D, which was equal to Q upon 4 pi epsilon naught R. In this, E is equal to F upon Q. This was the value, and this the potential. The potential is very important in electric field, because if we talk about the sources, that we have the voltage, it always have higher potential and the lower potential. So V is the potential, that was defined as E dot D, that was Q upon 4 pi epsilon naught, and the definition for that was amount of work done, that was amount of work done bringing a unit positive charge, bringing a unit positive charge from infinity to that point was called potential. What is a potential? If we will, in the next slides we will see what is really what the potential. So starting with this Coulomb charge, or we can say the charge, we can see the two figures like this, figure number 1, and this is the figure number 2. This, if this is Q1, this is Q2. For example, this Q1 is stored. This is the water that has been stored, and the movement, we can say that the movement of charge is zero in this till some external force is not there, not present. In this case, we are saying that the Q2, this is the charge that is moving from up to down. This is known as the potential. If we talk about the higher potential, and this is the lower potential, or we can say it higher height, and this is the lower height. So the movement is from this point to this point every time at t is at t greater than, or we can say that the time period is always having some time. At every time Q1, Q2 is changing its position. So this is the movement of the current. If we say, if in our simple language, we can say that the water current. That means the water current is moving from up to down. So this potential, this is the potential that is known as a higher potential to lower potential. The every charge will flow from higher potential to lower potential. This, the movement of the charge, that we said water current, the movement of the charge, that is dq upon dt, is current. In basic electrical, we can, it will be easy to understand, the movement of the charge is known as the current. So now, what is a current? What is the charge? The basic thing is that the charge is the electrical property of an atomic particle, of which matter consists made in coulombs. In the coulomb, we are measuring the unit of the charge, and this is the value. That is, one electron is equal to minus 1.602 into 10 raised to power 19 coulomb, whereas 1 coulomb is equal to 6.242 into 10 raised to power 18 electron. That means this is the value of the charge, and this is the electron flow only when, as we said that the in the figure 1, we have said that the till the external source is not available, it is, the water is not going to move. So in basic electricals, or we can say in the electricals, the external source is the voltage or the current. These are the two elements that derives the system. So we have the electric field. This electric field, this represents the positive, as we said that the higher potential is needed and the other terminal will be the lower potential. So when an external field is applied, what happened? This is the positive, this is known as the electric field. Due to the field, the movement of the charge, per, that is the Coulombian force, will move with the charge. So if we talk, this was all in electrostatics. If we talk about the magnetic field, the rate of change of magnetic field, that was, if for example if we take the magnet, it have the two polarity, that's the north and the south, and this is the north and the south, this is the conductor that has been placed, where the dot means when the conductor is inside, when it is for example, if this is the copper bar, if this is the iron, and I am putting some wire in it. So the wire that is going, that is known as the, if it is going inside, so it is kept as cross, and when at this point it is coming outside, so it is known as the dot. That means this is sign convention. So this is how, whenever the magnetic, when a current carrying conductor is placed in a magnetic field, it experiences some force. So everything, this was the charge, this is the magnetic field. So coming to the current, as we said that the rate of flow of charge, di over, that is di at the in frame to the time, will be said at dq upon dt, that is rate of change of charge. This is, for example, if 1 coulomb, we have taken one example like this. This is the pipe. We can say the water pipe is there, and we have to flow something in it, inside it. If, for example, it is a water current, like we said, the water current, the water is going to go inside this, which having the area that is 1 mm square and the length that is 1 m. So 1 coulomb was equal to 6.24 times per 18 electron. So when there is a movement of this charge from this point to this point, this is flowing from this direction to this direction, then the rate of change, that is known as the current, it is also expressed in T naught into 2 I dt. I is equal to the Q upon T, that is Q was the coulomb and T was the 1 second charge, then it will be said to be 1 ampere when 1 coulomb of the charge is passing in 1 unit second. So now what we have done, this is the two figure 1 and figure 2. What we are going to draw, this is a pipe, we can say it is a single pipe, we can say the water pipe, as it is really, as we all have seen that water pipe. So what was the water pipe, we are putting some water inside that. This we can represent by the charge. This charge is flowing from the 1 mm square, and this is a normal condition. That means we have some, we are we can insert some pressure in this point also. This is a normal case when we are not inserting any pressure. So all the current, all the charges that was coming from this will pass from this, as the external source is there. The external source in this is the pressure, and when we talk about the electric system, we have the voltage. We have the voltage or the current that derives the circuits. Now in the second case, what happened? We have inserted some force here. For example, this was the water pipe. What I put, I have some insert some pressure on it at this point. What will happen? It will become like this because we are inserting. Now what will happen? The pressure at this point, or the voltage, or the pressure at this point, this at this point, third point, is not having the same. That means V1 is equal. At this point, it is not equal to. So this is known as the resistance. We can say this was the externally what we have did. We have put some pressure on. So the resistance is a physical property or the ability to resist the current. What we were doing there, we were resisting when in the pipe. What we were doing, we are resisting it by putting some pressure. What will happen? We can say that the area has decreased, so the pressure will increase higher rate, and then again with that point it will become same. So this is the pipe which is in which the water is flowing, or the charge that is flowing, which have the length 1 meter, and the area is this 1 meter square. So the resistance is defined as resistance equal to rho L upon A as it is given, where the rho is known as the resistivity of the material. The resistivity is that that is based on the material, what we are using it. So if according to this formula, what we are saying with if the area is increased, the resistance is going to decrease. If area is decreased, then the resistance is going to increase. So this is the basic concept of the resistance. So the resistivity, as we were saying, that is the rho. This is the this this shows the different resistivity of the material, that is here. Now coming to the next slide, as we have studied, what we have studied, as the moment of the charge will represent to the current, the flow of the positive charge potential is known as the ampere, rate of change of charge, or I is equal to dq q upon t. 1 ampere is equal to 1 coulomb of the charge transfer in 1 second. That was equal to this value. So the charge 1 coulomb, this is the simple representation what we are saying. Now charging a current. Now what we have taken, this is the potential V, this is the current, and this is the material that we were taking. So from this material, the current is going to flow when the circuit is closed. Circuit is closed. That means the voltage at the positive and the negative are connected with some resistive element. Then the charge in the electric property of the atomic particle, which consists measured in the coulomb, that was this this is the electrical circuit. Now this material can be a resistance, and the rho, that was the resistivity, it will change its property. So that's why in the 12th we used to study the resistance, that we were having the different sign conventions, the different color coding is there, so that we can understand how much is the resistance of the circuit. So when we have studied that resistance, then we have the current. The rate of change of flow is known as usually the current rise with the time. This is the DC circuit, and this represents the AC circuit. Now the question arises sometimes in the interview or in exams. It is asked which one is more dangerous, either DC or the AC. So DC have the frequency that is zero. Frequency means that if we talk about the time period was 1 upon f. That means if we are saying that t is equal to 1 upon 0, the frequency is this. The time period is nothing because it is not changing with the time. But frequency, if we need to calculate 1 upon 0, that means that's not possible. So the voltage remains same at every point. If I will check at this point, this point, this point, this point, the voltage is going to remain, or the current is going to remain. Whereas in case of AC circuit, if we talk about the AC circuit, we have, and like in India we have 240 volts, 220 to 240 volt supply with a frequency of 50 hertz. That means 50 hertz means that the time period is 1 upon 50. 1 upon 50 means that is in 1 second it is taking the 50 cycles. 1 second it is taking a 1 second it is taking the 50 cycles. So that's why it is pulsating. That means from 0 to 240 it is going to rise. Then again from 242 it will be 0. Then again it will be minus 240 voltage. And then again 0. And it will keep on moving. It will keep on moving. So this is the DC, that we have to remember that the DC have the frequency of 0, whereas AC have the frequency that is in Z hertz, or we can say A hertz. This A can, in India it is 60, and if we talk about the USA, in India it is 50, in USA it is 60. And in USA we have the voltage of 110 volt with the frequency of 60 hertz. What's the advantage of using this? This is the lower voltage value and this is 60, so it is taking the 1 upon 60. We can say that that means that the time period, that is, it is in 1 second it is taking the 60 turns. So coming to the current symbol, now we have the sign conventions. Like sign convention is really very important, because if we go for the different books, they have the different time conventions. We have the different way of thinking. For example, if I'm taking one circuit, I'm saying that if the resistance is going inside that this circuit, this is going to be the positive and this is going to be the negative. As If we complete the circuit, we'll go from this point to this point to this. So it's the convention what we are taking. For example, if this is the point and the current is going inside it and it is getting like this. So in my convention, this I is equal to I1 plus I2, we can say. And this was the positive terminal that has been split into positive this, positive this. So in the circuit, we have taken from this the current that is moving, that is the direction of the current what we are taking according. In this circuit, this was a voltage source that was connected with a positive and negative terminal, and the current, this is the current that is flowing from the resistive circuit at this point and that's coming out. That means we are saying that the current that is going inside at this point is positive, is positive, and when it is coming at this point, it is the voltage that we are having is negative. This is the sign convention. So when we are taking the voltage, the plus sign represents the positive terminal, or somewhere we say it higher potential, it represents the higher potential, and negative sign shows the lower potential of the circuit, lower potential. And very interesting thing we have right now, that is if we consider Earth, the Earth potential, that we can see that the Earth potential, that is V is equal to 0. That means this is the lower potential. So whatever, whenever, if we are thinking about the things like the lightning stroke take place, or any protection earthing is there, the Earth act as a zero potential. That means everything, either voltage or the current value, will go directly into the Earth's surface. So coming to the voltage, energy per unit charge created by separation, that is V is equal to D upon dq, that is the energy in joules upon charge in coulomb. That was as we have studied. So 1 volt is equal to 1 joule per coulomb, that is 1 Newton meter per coulomb. Then we have the voltage energy required to unit charge through an element. That is, it, this much electron of 1 coulomb charge is transformed separately through through an element. This is the sign convention again. We are taking about the voltage sign convention. This V12 is equal to V12. What is the difference between this? What is the difference? This is the representation. That means, if for example, if I take this as a negative and this was the positive, if I take this negative and this positive, so it is a moment. That means if we change the direction, the current direction will be this one, and if we take this one, this is a simple. Then we have the other concept, that is the power and the energy. The power is the rate of change of energy, that is dq by dt, whereas 1 watt is equal to 1 coulomb per second. And if we convert this into the volt ampere, what will be the P? We know that dq upon dt, dw upon dt, that is a work done per unit coulomb. And if we need in the terms of dt, we have this represents the current, and dw by dt represents the P, that represents the V into I. So that is the power generated by the source will be equal to the voltage and the current that is going into the circuit. So this is the next topic that we have, the law of conservation of energy. That means this: thus the total power supplied to the circuit must balance the total power absorbed. As we have studied that the energy cannot be created nor be destroyed, but it can be transformed from one form to another. The best example for this is the motor, generator. We are transforming, that is the motor, we are taking the electrical energy and then we are converting to the mechanical work done, mechanical energy. In the generator, we are taking the mechanical energy and just converting into the electrical energy. So this is the conversion. So it is written as W is equal to, that is the lower limit and the upper limit P dt, that is represented by the P can be transformed into the voltage and the current, and this can also be transformed like this T naught to T, and we have the voltage with the current, that is the rate of change, that means change. Then we have the energy, that is the capacity to do the work, is known as the energy, that is unit is joule. 1 watt hour, that means 1 watt was equal to 3600 into joules. We have converted into hour into seconds. So this was the basic that we have studied. We have studied what is charge, what is potential, what is current, what is work done, what is power, what is the law of conservation. So by knowing all these things, we will be going to start the network part. That is the network part. So in the next, we will start the basic elements and the classifications. Till then,